So we're going to learn about correlation. Tell me what you already know about correlation. Anything? It's when things correlate. That was solid right there. I love that, Emerson. Let's go. All right. What else? What is correlation? What does that mean to correlate?
Like two things comparing.
Two things and like how they kind of compare or how they're associated with each other. Okay? All right. Yes. So we're going to talk about correlation today and what it is. So in the previous lesson, we discussed direction, outliers, form, and strength, DOFs, right? So we talked about direction of a scatter plot. If there's an outlier, the form is either linear or nonlinear. And then for strength, we were like, oh, it's either weak, moderate, or strong, right? So correlation actually gives a value to the strength. So to quantify the strength of a linear relationship between two quantitative variables, we're going to use correlation. Correlation has the notation of a little r. So little r. That's correlation. Everybody got that? Royce, are you with us?
Yeah.
Perfect. Everybody got this? Good? Yes. Moving on. Let's go. All right. Correlation R is the measure of the strength and the direction. So when we get a correlation value, we're going to know from that value the strength and the direction of a linear relationship of two quantitative variables. So strength and direction, here we go. Tell us about R. The correlation R is it is going to be a value between -1 and +1. Correlation has to be between -1 and +1. It cannot be any other number. If you get a correlation of -3.2, you did something wrong. You done goofed. Okay? If the relationship is negative, if you look at a scatter plot and you see a negative trend, that means your correlation has to be negative. So if you see a negative trend, then your correlation is negative. Okay? If the relationship is positive, your R should be positive. So R should be bigger than 0 if you have a positive trend. Okay, what if R is exactly 1 or -1? That means you have a perfect linear relationship and all the points will be exactly on a line. So it'll be like connect the dots where you could draw a line straight through it, and that would be a perfect 1 or -1 correlation. Obviously, the positive one would be if it's a positive direction. -1 would be if it's a negative. What's up? Okay. If there is very little scatter from the linear form, then R is going to be close to 1. So basically, the closer it is to a line, the closer to 1 or -1 it will be. The more scattered it is, the closer that R is to 0. Okay, the more scattered, the closer R is to 0. Cool?
Can we go back for a second?
Back to what?
The last one.
To this. Cool. All right, cool. So that's all about correlation between -1 and +1. All right, look at those graphs. Here are some examples of some correlation. This has a correlation of 0. There's really not a linear pattern. I really can't tell if it's positive or negative. It's just dots on a thing, and they look like a big old fat O. Okay, so it looks like a 0 because there's no correlation there. This one has a correlation of -0.3. It's negative. Can you guys see the negative trend there? Okay, and it's 0.3 because it's like kind of like starting to form a line, but it's not really close. This one's 0.5, positive 0.5. There's a positive trend. They're a little bit closer together. They're kind of starting to come in. -0.7, negative trend, coming in further and further. Positive 0.9, there's a positive trend, and look, now they're really starting to get close to a line. And then this one is -0.99. Very, very strong correlation there. Okay.
So wait, the stronger the correlation, the more linear it is.
Yeah, sort of. The closer it is to a 1 or a -1, the closer they are to making a line. So, yes-ish. Yes. All right, cool. So we're gonna do a little game here to see how good you guys can do this. All right. So we're gonna go to this little applet here, and we're gonna try to guess some correlations. And then there's actually another game that we'll play in a minute, but this one's pretty cool. I like this one because this one will actually allow us to do positives and negatives. The other one doesn't. It's only positives. If any of you guys know someone who's taking AP statistics, they actually had an extra credit last quarter where they had to play a correlation game and get a certain score in order to get the extra credit. So it was similar to what we're about to do here in just a second. If it comes up. Here it comes. La-di-da.
People are just taking the time to learn.
Yes. Are you cold?
It feels good. It's awesome.
All right. We got it. Freezing.
0.99.
0.99?
Yeah.
0.99. There we go. That one was 0.986. Look at y'all. Okay, let's try again. How about this one? Oh. First of all, look at this. Do you see a positive or a negative
That's a
trend?
negative.
Negative.
It's going positive.
No, it's negative.
Are you saying it's 0?
I don't know.
It's positive.
Let's just check 0. Okay, it was negative. Now that one was tricky. I don't know that I would have seen the negative there. So, okay, let's try this one.
Positive.
I think
Positive 2.
Positive 3.
0.2,
Positive
0.3,
Yeah.
Yeah.
0.3. Okay. Oh, yeah. All right. Okay, 0.361. Okay, not bad.
Positive 8.86.
Bro, what?
There's no way that's 0.8. They
That's
have to be
0.2.
close to a line to be.
0.6.
No, it's
I
0.2.
think 4.
0.4?
Yeah.
0.4.
0.54.
0.4? Oh, wow. Okay.
What do you say? 0.9?
All right, how about this one? It is negative. You guys see the negative at least?
Yeah.
Okay, what do you think?
Like a 2.
Like a 2?
Negative 0.31.
Oh, wow. Wow, you're not terrible at this, Xander. Okay, what about this one?
Negative 8.
Negative 0.8?
7.
0.75. Okay, cool. This one?
Positive.
We'll do 3 more.
Positive
Positive what?
8.
6.
0.8. 0.8.
0.67?
Yeah.
That wasn't bad. Okay, 0.5. Okay, what about this one?
It's negative 8.
Negative 0.8?
Oh, so the higher you go, the more like straight it is.
Yes, the closer you're getting to 1 and -1, the straighter it's becoming. Yes. Yes. All right, last one. Come on. Let's get this one.
That's a
4.2.
0.42?
Yeah, straight.
Do you guys think he's anywhere close?
I think it's 3.2.
You think it's 3.2?
I just he's
3.5.
been actually pretty accurate this entire time. So
3.1.
3.2.
Yes, you did. Yes, you did. All right, very good. So, obviously, you guys have the link for this applet. And so all you do is you go to that link that it says right there where it says rossmanchance.com/applet and then click guess the correlation. Here's another correlation game that actually has sound effects and is more game-like. Guessthecorrelation.com. It's called guessthecorrelation.com. And Now, I will say these are all positive. Now, with this one, you have 3 lives and you get points. So this was a little bit more fun to play. What do you guys think about that one?
That's like 7.
0.7?
I feel like it's more.
So for this one, it tells you the true R value. This was 0.9. We guessed 0.7. We had a difference of 0.2, so we lost a life. You have to be within 0.1 to get a life, or to not lose your life. What about this one? They are all positive on this game. That's the only bad thing about this game.
Point, what is it?
0.1? 0.2? 0.15. All right, we'll split the difference. That one was 0.29.
What?
How about this one?
That one.
Like 5.
Point
4.
5, 4, 6, what?
5.
0.45?
Yeah.
Oh, we are terrible. So that's another one we can play. GuessTheCorrelation.com. I'll put those links in our Canvas. But those are kind of fun to play. I want you guys to know this though. I don't want you to worry, okay? Because I would never, ever put this on a test and say, tell me the correlation. Like, that would be terrible. That would be horrible. I would be a terrible person for that. Here's what you might have to do, okay? You guys see, you remember these 6 scatter plots here, or whatever? Maybe what you would have to do is take these 6 scatter plots and these 6 correlations and match them, okay? But they would be pretty different like these would be. So it would be a little bit obvious. Or maybe you would get 6 scatter plots and you would have to put them in order from weakest to strongest, okay? But you would never have to look at this and go, that's 0.5, Miss Lakey, because that, I don't even know what that is. So it's just one of those, like, you kind of guesstimate, okay? So don't worry about getting it exactly right.
How does they know what the exact correlation is?
Yeah, so there is a formula that you'll see it on the video tomorrow. It's kind of a scary formula. You don't ever have to calculate correlation. You only have to be able to look at it and interpret it, and that's what we're about to do now. Okay, so good times. So here's a couple of examples of just some quick examples of some word problems on how correlation might look. So for each of the following relationships, we want to say is R positive or negative? And then do you think it's closer to 0 or 1? Okay, so that's kind of how you would have to do this. So the 24 students in Miss Child's statistics class performed the candy grab activity like we did last week. Here's a scatter plot showing the relationship between hand span and number of Starburst candy grabbed for those students. Note that only 23 points appear because 2 students had the exact same hand span and number of candies. So what do you guys think? First of all, is this positive or negative? Yeah, so R is going to be greater than 0. So that's the first thing. On this one, R is going to be greater than 0. And then, what do you guys think? Is R going to be closer to 1 or closer to 0? Yeah, so that's exactly how we would answer this. We would basically just say R is going to be greater than 0 and closer to 1 than 0. Okay, because we can see an obvious trend here. We could definitely see that line forming. And so R is positive and closer to 1. That's pretty easy, yeah? Cool. All right, so there's that. Let's look at another one. This is an example of... to see if seat location affects test scores, a statistics teacher randomly assigned students to seat locations in the class for a particular chapter and recorded the test score for each student at the end of the chapter. The explanatory variable in the experiment is which row the student was assigned and where row 1 is closest to the front and row 7 is furthest away. Here's the scatter plot showing the relationship between row and test score. Do you guys think that R is positive, so greater than 1, or greater than 0, or is R negative, less than 0? Yeah, so this one, R is less than 0. And then what do you guys think? Do you think R is going to be closer to 0 or closer to 1 here? Yeah, so R would be closer to 0. Okay, so not too bad, right? Hopefully that's doesn't scare you too much. It's not really that hard. Awesome. Next. All right. The scatter plot shows the relationship between 40-yard dash times and long jump times. The distance, and long jump distances for a small class of 12 students. Now, we have been given the correlation this time. It's negative 0.838, and we need to interpret that. So what does that tell us about the correlation of these two variables? Correlation tells us two things, strength and direction. So how strong do you think this is? Is it weak, moderate, or strong? Yeah, this would be strong. So I'm going to tell you guys, most of the time, anything less than 0.5 would be considered weak. If you're between 0.5 and 0.75-ish, moderate. 0.75 to 1 would be strong. Now, it kind of, like if somebody says, hey, here's a correlation of 0.76, and you say it is moderate, nobody's going to blink an eye. It's going to be fine. But those are kind of the cutoffs. So 0.5 down towards 0, that would be weak. 0.5 to 0.75 is moderate usually-ish. 0.75 and higher is strong. So yeah, this would be a strong association. And then, so there's our strength. And what about the direction? Well, I can look at the scatter plot and see that the direction is negative. I can also look at the R value, the correlation value, and see that it's negative. Okay, so this is strong and negative association. Easy enough? Any questions on that? Perfect. Alrighty. Yep, we already did that one. Moving on. All right. This is important. A correlation close to 1 or negative 1 doesn't imply that an association is linear. So this is kind of why when Royce asked the question that he asked, I was kind of like, not exactly to what he said, because he said, is it that it's linear the closer it is to 1? Not totally. Here's why. This association is not linear. Do you guys see the curved pattern? Okay, it's a little bit curved, but it does have a correlation of 0.93 because it's close to the pattern that it's making, okay? So it does have an R value, but correlation alone does not tell me the form. So if I have a correlation value of 0.93 and I don't see the scatter plot, if I had only given you this number here, I couldn't automatically know for sure it was linear. To determine the form, you have to look at the scatter plot. Okay? So don't be pulled into the trap of, R is 0.93, must be really linear. No, that just means it must be strong and positive. Correlation only tells you the strength and the direction. It doesn't tell you for sure that it's linear. Does that make sense? Okay. All right. While the correlation is a good way to measure strength and direction of a linear relationship, it does have limitations. Have you guys ever heard this phrase, correlation does not imply causation? Have y'all ever heard that? No? So just because two things are correlated doesn't mean that one is causing the other to happen, okay? So two variables might have a really strong correlation, but doesn't mean one thing is causing the other to happen. So one example is sleep and grades. Did you know that your amount of sleep that you get is heavily, strongly correlated to your grades in school? It is. The more sleep you get is correlated to having higher grades. Okay? That is a very, very proven thing.
You should move start time to 8:30.
But here's the problem. Does that mean that if you get more sleep, you're guaranteed to get more grades or higher grades? No. So there's correlation for sure, but that doesn't mean that one thing's causing the other to happen. Okay? So I'm going to show you guys here a bunch of examples of this. Here is a scatter plot showing the relationship between total revenue generated by skiing facilities in the United States and the number of people who died by becoming tangled in their bed sheets for 10 years. The correlation is 0.97, you guys. That's very, very, very strong correlation. Does that mean that if we have a lot more people skiing, that a lot more people are going to die? No, not necessarily, okay? So again, just because two things are correlated does not mean that one is causing the other to happen, okay? So the reasoning here is this. There's probably not a cause and effect. There is a strong and positive correlation. An increase in skiing revenue is not going to cause people to get tangled in their bed sheets and die, okay? So again, how can you reason this away? Literally by just saying correlation does not imply causation, okay? Correlation does not imply causation. Correlation does not imply causation. That's basically the most important thing to say there, okay? I want to show you guys a bunch of other ones real quick. These are pretty funny. Some of these are really funny. So, this is a website called Spurious Correlations. So this is the U.S. spending on space, science, and technology has a correlation of 0.997 with suicides by hanging, strangulation, and suffocation. Does that mean that if we spend more on science and technology, that more people are going to commit suicide by hanging, strangulation? No, it does not mean that there's a cause and effect. That just means that they happen to be very strongly correlated because there's the same pattern for some reason, okay? Let's see. Do you guys ever watch any movies with Nicolas Cage? Did you know that if Nicolas Cage appears in a film that there's going to be more people drowned by falling into a pool? Is Nicolas Cage causing people to fall into pools and drown?
Yeah.
Obviously, right? This correlation is 0.666, which that's just weird anyway. But anyways, there is a strong correlation there, but that does not mean that people are drowning because of Nicolas Cage.
He was in 66.
Proves that he's literally guilty.
Yeah, I mean, right, literally put the man on trial, right? Per capita cheese consumption and people who are tangled in their bed sheets. So obviously you guys, it's so crazy. Like, so many things can cause you to be tangled in your bed sheets and die. It's craziness. 0.947 is that one. This one's one of my favorite ones. The divorce rate in Maine is correlated with 0.992 with the consumption of margarine. Can you just imagine? So apparently in Maine, if you go to the store and you buy margarine and you go home, like, woman is like, I'm done. We're done. I'm divorcing you.
This is what you put on bread, right?
Yeah, for sure. Absolutely.
Butter?
Yeah. Margarine is like butter. It's like fake butter. It's like chemical butter. So if you bring that home to your woman in Maine, she's divorcing you. We're done.
Probably like
Right? Okay. Miss America. Have you guys ever watched a Miss America pageant? Depending on her age, that correlates with murders by steam, hot vapors, and hot objects. Just saying. So, like, this goes on, literally, this website, it goes on forever and ever and ever. They're so, like, I know, right? Isn't that crazy? I mean, obviously, you guys, if Miss America is younger, like, she must be killing people with her hair straightener or something, right? Like, steam, like you're dead. So, like, that's, again, exactly why. I mean, these go on forever and ever and ever. There's so many of these. So again, all of this to say, just because two things are strongly correlated does not mean that one is causing the other to happen, okay? All right. So let's look at our example and then we'll be done. Most people love chocolate for its great taste, but does it also make you smarter? Does chocolate make you smarter?
Yes.
All right, let's see. A scatter plot like this one
It actually like increase
it very well could. So let's see. A scatter plot like this one recently appeared in the New England Journal of Medicine. Each point on the scatter plot represents a country. The explanatory variable is the chocolate consumption per resident. The response variable is the number of Nobel Prizes per 10 million residents. All right, here's the correlation. 0.791. Tell me what that means. What does this mean? 0.791.
That's the correlation.
And what does it mean? Interpret it.
Is it strong?
A strong positive correlation. Perfect. That's exactly right. There is a strong positive correlation. Okay. So, here's the question then. If there's a strong positive correlation between eating chocolate and being smart, or winning Nobel Peace Prize, if people in the United States started eating more chocolate, can we expect more Nobel Peace Prizes to be awarded in the United States? Why not? They're strongly positively correlated. No, correlation does not imply causation. All right. So, again, make sure you guys, just because you get a strong correlation, do not ever think that that means that there is a causation. Okay?